All right, now we're going to be converting from standard to vertex form and interpreting quadratic functions. So the first thing that we're going to do is we're going to look at how to go from standard form to vertex form. So standard form, right, everything needs to be written out in its separate terms, so quadratic, linear, constant. In vertex form, things are grouped together, right? So I can see the vertex, HK. Now, if I wanted to go from vertex to standard, that's pretty easy. I just multiply out x minus h times x minus h, and then I would combine like terms. But to go the other way, I need a few additional pieces of information. So, looking at my standard form and looking at my vertex form, what are things that they have in common? Well, they both have a. So that means looking at my standard form, I already know the value of a. A is going to be 1 for this particular problem. Now, what else do I need for vertex form? I have a already, and I need h and k. Well, looking in standard form, I don't know h and k just by looks. I need to find the vertex, right? So h, again, remember, is negative b over 2a, and k we're going to find by plugging back into our formula to find the y-coordinate. So let's go ahead and do that. So to find the x-coordinate, our h, that's a negative b over 2a. So my a for this problem is 1, my b is 4, and my c is negative 5. So negative 4 over 2 times 1, negative 4 over 2 gives me negative 2. So my x-coordinate of my vertex is negative 2. Now I go ahead and I plug it in to find the y-coordinate. So the y-coordinate is going to be, it's a little light. The y-coordinate is going to be negative 2 squared plus 4 times negative 2 minus 5. So that's 4 minus 8 plus, minus 5. So 4 minus 8 minus 5 is going to give me negative 9. So the y-coordinate of my vertex is negative 9. So to write in vertex form, the only thing I need is a, h, and k, and I have all of those now. So I go straight to my vertex form. So a we said was 1. That's x minus h. H is negative 2, right? Here's my h, here's my k. Squared plus k. So simplifying that, I don't have to write that 1, right? And then x minus negative 2 is x plus 2 minus 9. It's an ugly 9. Minus 9. So that is going to be my function written in vertex form. So these two guys right here, this guy in vertex form and this guy in standard form, are exactly the same function. If I were to graph them, they would look exactly the same. They're just written in different ways. So when are we ever going to use this stuff in real life, right? Well, parabolas are actually found very often in real world scenarios, whether in nature or whether in architecture or whether we're describing the projection of an object. So looking at this picture, you can see that the structure of this arch here is a parabolic shape, okay? So the bridge structure is actually a parabola that is modeled by this equation here, all right? Now what we want to first figure out is how high is the arch above its support. So how high is the arch? So down here is where it's meeting the river. So how high is the arch? What is that asking me to find? Well, we want to know the highest peak of the arch. Hopefully it's coming to you. I want to know the maximum value. I want to know the max value of that arch. Well, that's going to occur at the vertex, right? It's going to occur at the y-coordinate of the vertex. So I need to figure out the vertex, right? So vertex, negative b over 2a. So first I have to find the x-coordinate. So you always have to find x before you can find y. So the x-coordinate of the vertex is negative b over 2a. So in this function here, my a is this value, and this is my b value. So negative 0.131148 all over 2a, where a is negative 0.001075. I'm going to go ahead and evaluate the bottom of this denominator first. Okay, now I'm going to evaluate that whole thing together in my handy calculator. Okay, so we get 60.999. We're going to go ahead and round to the nearest whole, so we're going to say that's approximately 61. So 61 feet. Now remember, that's the x-coordinate. That's not the y-coordinate. So what does the x-coordinate represent in this? Well, if we kind of treat this like a coordinate plane, here's the the y-axis, here's the x-axis. If I'm looking at the x-coordinate of my vertex, I'm looking at the distance from 0, 0 to where my vertex is. So this distance right here is 61 feet. All right, now I want to find this distance here. So I need to go ahead and plug back into my function. So f of 61 and I'm going to go ahead and evaluate that. Okay, so once I evaluate everything, I get about 3.9999953, so we're going to say that's approximately 4 feet, okay, which means that the distance here is 4 feet, okay, so this is a very low bridge, right? So here that's 4 feet, so how high is the arch above its support? 4 feet, so the answer to part A is 4 feet. All right, so this part of the question asked me, how long is the section of bridge above the arc? Okay, so here is the arc of the bridge. So we want to know how long this section of the bridge is. Now I hope you can see that this is also equivalent to how long this section of the bridge is, right? These are the same. Now in the last slide, we looked at how this is like the coordinate plane, right? Here's my 0, 0. My vertex was here, and we said that this distance was 4 feet. We found that by finding this distance to be 61 feet. Now, you have to remember a quality about the parabolas, which is that this is where my AOS is, right? This is where my AOS is. Therefore, if I know that this point right here, 0, 0, is a point on my graph, then its reflection point will also be a point on the parabola, right? These two are points. So from here to my AOS is 61, its reflection point will be from the AOS to that point. Therefore, this distance is also 61 feet. Hope you're following. If not, maybe you need to pause and rewind and watch again, okay? So, what's the total distance going to be from the span of the arch on the bridge? Well, I need to add those two values together, right? 61 feet plus 61 feet. And we're going to get 122 feet. So if you walked from where the arch starts to where it ends on top of the bridge, it'd be 122 feet. All right, so we are launching an object into the air, and the path that that object is going to follow, right? You throw something up, it comes to a point, and then it comes back down, right? So the path that this object that we just have thrown into the air has this equation representing its height at time t, okay? So here, h of t is normally where our y is, right? So our y is acting like h, and t is where our x usually is, so x is acting like t, okay? And we want to know what is the maximum height that the object will reach. So when I throw it up in the air, when it gets to this point here before it starts going back down, how high is that? We want to know how high that is. Well, hopefully you realize that that's also the vertex, and we're looking at the y-coordinate of the vertex, right? It's the y-coordinate that is going to tell me the max height, because remember, when we're talking about y, we're talking about h in this problem. So, in order to get to the y-coordinate of the vertex, I first have to find the x-coordinate. So negative b over 2a gives me the x-coordinate. So that's negative 19.6 over 2 times a. Evaluating that, I end up with a nice pretty number like 2, which means that at 2 seconds is when it's going to hit its max height. So now I need to plug that into my function. So h of 2 is going to be negative 4.92 squared plus 19.6 times 2 plus 58.8. Evaluating that. All right, so h of 2 is 78.4. Remember, height is measured in meters in this problem. So our object is going to reach its maximum height at 78.4 meters, and that's going to be the y-coordinate of our vertex, remember. The next question says, when will the maximum height be achieved? So remember, we threw our ball in the air, it hit a max height, and it came back down. The max height that this occurred at was our vertex, right? So the max height is our vertex. And in order to find that our max height was 78.4, we had to find the x-coordinate, right? What was the x-coordinate? It was 2. Now, what did that mean? So x was 2, but remember in this problem, our x is acting like t. T is talking about time. So when I got x equals 2, I was talking about time. So that means it took me 2 seconds after I threw the object until it reached its maximum height. So that was the x-coordinate of the vertex. So let's say we have Pierre, who is a mountain climbing ant. Now Pierre only likes to walk from left to right, which means he likes to start at the far left of a function and continue to the right side of the function. Now when Pierre is climbing uphill, we say that the function is increasing. So if you start Pierre here and he climbs uphill, Pierre is increasing on this interval here. So this interval is going to be, well, the far down here, this arrow tells me we're going to keep going forever and ever. So Pierre was increasing from negative infinity until he comes to a resting point, which is going to be right here at 0. Now I can write it this way, or I can write it this way. So he is increasing on this interval. Now we can also go uphill the other way. So if my function is concave up here, then we can increase this way. So you can see how Pierre is climbing uphill as well here. So what is that interval? Well, I was at a resting point here at 0, and then now this arrow tells me I'm going to positive infinity. So that's from 0 to positive infinity, or you can write it like this as well. So whenever you're talking about intervals that you are increasing, you are talking about x values. So whenever Pierre is going downhill, our function is decreasing. So whenever he's sliding down the function, Pierre is decreasing and the function is decreasing. So what intervals is this happening? Well, here's the resting point 0, and then it's going to decrease from there. Now, even though we're going down, remember the x values are actually getting larger on this side of the coordinate plane. So at our resting point 0, until the x values are getting very large, that's 0 to positive infinity, or of course you can write it this way as well. Over here, you can see Pierre sliding down into the cup, into the function here. So where does it start? Well, these are all the negative values of x. So this is negative infinity over here, and then we're going to stop here at 0. And of course, you can write it this way as well. Whenever Pierre is sitting at a maximum or minimum value, he is not moving at all. So since he's not moving, he's not climbing uphill or downhill, which means the function is not increasing or decreasing. So the function is neither here. The function is not increasing or decreasing whenever we're sitting at a max or a minimum value. So this quadratic function is in standard form. We want to rewrite it in vertex form. All right, guys, go ahead and give this one a try.